today's daily. Oh, I have already solved this problem before. But what is this problem? Okay. Count unguarded cells in the grid. M and N representing an 2D integer array. Guards, walls. Okay. Starting from the precision on this obstructed by okay. Okay, so we have to return the number of unoccupied cells that are not guarded. Okay. Guard. 0 0 1 1 2 3. Okay. Oh. M times N is more than 10 power 5. Guard length. This. Okay. Okay. Guard. I'm thinking that if we really build the matrix, would it be too slow or not? Perhaps that could be. So for that, the time complexity would be the M times N, right? Okay. So and M times N times N. Okay, so the grid is equal to 0 times I'm not sure whether this will TLE, but we can try it first. So we got n columns and n, right? Times n, right? for so this is guard. Okay. All right. Oh. I think the time complexity wouldn't be all of n times m because we cannot do the early stop over here. So if we have a guard over here and we can go through 4 directions, right? And here is top, and then we stop, and then we can go all the way down, go all the way left, and go all the way right. But we cannot mark this position as visit because if we want to start from this guard, if we mark this as visit and then we go to top and this is a visit, so we will stop and this position should be guarded, but we cannot visit there, so we have to go through each directions. So yeah, this is not a good idea, but I think the other way to do so is using some DAG structure to store well, G guard. Okay, so suppose that the guard is on this row, and this row, there is no wall on this row, and the guard can handle every position in this row, right? Okay, So for every guard, we want to check out the row and the column he guard, and to check if there is any wall on that column, and then we can calculate this guard can guard how many position, right? But is that really efficient? Guard wall here. Okay, so I'm thinking about that. Perhaps we can create a hash map. It looks like we got a row. So this perhaps looks like well. Row. And columns. And one more, it looks like columns and rows. And we can have a of1 lookup time. And well, actually I do not have any ideas right now.
A guard can see every cell for cardinal directions.
I think I'll stick to the brute force way and see if we got TLE, then we can think about some new approach to do so. Okay. 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 We have 4 directions, right? So top, but, left, right, arrange. The R subtract 1. Right, and bottom is R plus 1 to M. And for left, okay, for right is C plus 1. N. Okay. Top C. Oops. If top C equals 2, break. Okay, if not equal to 0, break, and otherwise that are top and C. Right. Oh, this code is too mess. But R left, R left. Right, GT. Right. And then finally we can return m times n, subtract length of guard, and subtract length of walls. And type of list. What? Oh. Okay. Our scene was. Okay. Okay, so this can pass the test, but I'm thinking if that there's any better way to do so.